For example 2, what we're going to do is we're going to analyze the graph of a polar equation. So we need to identify our conic, r equals 3 over 2 minus 4 sine theta, and then we're going to sketch its graph. Don't freak out yet about the sketching of the graph, but you can freak out a little bit. So if we start off with the equation r equals 3 over 2 minus 4 sine theta, remember what we need to do is we need to get a 1 out here in front of the plus or minus. So we need to divide everything by 2. So if we divide everything by 2, that will give us the equation of 3 halves over 1 minus 2 sine of theta. What that tells us is then with the number in front of your sine, that is your e. So if e is equal to 2, then that is that between 0 and 1? Is it equal to 1 or is it greater than 1? Obviously, if you haven't missed math for the last 12 years of your life, 2 is greater than 1, so that means we're going to have a hyperbola. So if you remember hyperbolas from back in Algebra 2, they have the shape that looks like this, or they could also be opening up and down, like so. So what we're going to do is we're going to plot one of these. We're also going to have, or your foci are going to be centered at your origin. So whether you have foci here or here, one of those is going to be, one of your focuses are going to be on the origin. So let's make a table of values. When we make a table of values, I'm only going to require that you plot 4 of them. Feel free to cheer. Maybe that's more of a scream. But we're going to put the 4 that are on your axes. So we're going to have 0, pi, over 2, pi, and 3 pi over 2. Because we're going to use symmetry to help us plot the rest of the graph. We know what hyperbolas look like, and we know they're symmetrical, so I'm not going to require you to put all those different values in like we did back in 9.6. So if we look at our equation and we plug a 0 in for theta, it doesn't matter if you use the original equation up here, which I'm actually going to use here, or if you use this one. I like using the original one because you don't have your fractions. So if we put a 0 in, sine of 0, so the sine over here, your y value as you go to 0 degrees, that is 0. So 0 times 4 is 0. 2 minus 0 is 2. 3 over 2 gives us a 3 halves. So we're going to go in the direction of 0 degrees. We're going to go 3 halves. Let's try pi over 2, which is 90 degrees. And if you plug a pi over 2 in here, the sine of pi over 2 is a 1. So we would have a 3 over, let me do it over here, 3 over 2 minus 4, because your sine of theta is 1. So that's a 3 over negative 2, which gives us a negative 3 halves. Plug in a pi. Your sine of pi is 0. Times 4 gives us a 2 minus 0 on the bottom. So you have 3 over 2, which is 3 halves. I see a little symmetry going on here. And then we're finally going to plot 3 pi over 2. 3 pi over 2, your sine of 3 pi over 2 is a negative 1. So negative 1 times 4 is a positive 4. So in the denominator here, you get a 2 plus 4, which is 3 over 6, or 1 half. So since we have 8 rings here, we're going to go by fourths, I think. That'll work out. So 1/4, 1 half. Every 2 circles is a half. 3/4, 1. 1 3/4, 1 1/2. So 3 halves. And then we'd have a 2 all the way out here. So we're going to plot each of these points. So let's go in the direction of 0. We're going to go 3 halves. So out here, dot. We go in pi over 2. It says pi over 2 is going up, but we have a negative 3 halves. So that means we're not going up to pi over 2. We're actually going down to 3 pi over 2. So we're going to go a distance of 3 halves, which is this circle, right here. And then we go the direction of pi. We go 3 halves, which is going to be out here. And in the direction of 3 pi over 2, we go down a half, which is right here. So remember your focus, this little dot right here, is at your origin. So that means that this graph must be going down like so, and then curving back up. So that's going to, actually your graph is going to look a little bit like the second one that we sketched over here on the right. And so it's going to look like this right here on the bottom. So that means that this part of your graph is going to be symmetrical, and we're just going to go out like so and to the right. So what you have is a hyperbola that opens up and down. Now for 2b, we're going to try this little problem here, and we need to identify a conic and sketch its graph. So what we get is a 32, r equals 32 over 3 plus 5 sine theta. I'm not sure why that is there. Why that little squiggly is there. It shouldn't be there. Let me see, can I do that? Oh, there we go. So if we have to divide everything by 3, because we need a 1 out here. Oh, I see why. Actually, I don't want this to be a 5. I do want this to be a 1 here. So make this a 1, not a 5. Don't let that be a 5. So if you divide everything by 3, that will give us r equals 32 over 3 all over 1 plus 1/3 sine of theta. So your e value here is going to be a 1/3, which means we are going to have an ellipse. An ellipse. So let's graph our ellipse. To make our table of values, you still only need 4. So we're going to use some symmetry here, make your life a little bit easier. So we're going to go 0, pi over 2, pi, and 3 pi over 2. So if you plug a 0 in, and we'll plug it into our original equation up here, so I'm going to erase this stuff. Except for I shouldn't have erased the 1. It's a 1 there. If we plug in a 0 for your sine, then that means sine of 0 is just 0. So 32 over 3 is going to give us a, what, 10.6? If we do that, so 10.6. Plug in pi over 2. Well, sine of pi over 2 is a 1. 1 times 1 is 1. Plus 3 gives you 4. So 32 over 4 is 8. Then we have pi. Sine of pi is 0. So once again, we're getting another 10.6. If you plug in a 3 pi over 2, 3 pi over 2 is going to give you, the sine of 3 pi over 2 is a negative 1. A 1 times 1 is a 1. Sorry, negative 1. 3 minus 1 is 2, so we're going to get a 16. So here are your ordered pairs. We're going to have to go by 2s. So each line is going to be 2. So we're going to have 2, 4, 6, 8. Who do we appreciate? Mr. Klein! Mr. Klein! No? I might get a rise also, but I guess not. Alright, so in the direction of 0, we're going to go 10.6. So here's 11 in the middle, 10.6 right about here. Right about here. If you go in the direction of pi over 2, we're going to go up 8, so that's 4 rings. That would be right about here. Go in the direction of pi, you're going to go 10.6, so 2, 4, 6, 8, 10, 12. Here's 11 in the middle, about in the middle there. That's a wonderful dot. And then 3 pi over 2, we're going to go down 16, which is all the way at the bottom. So our ellipse, now think about this, is your orientation going to be on the y-axis or the x-axis? Would it be symmetrical by your x or your y? Well, because of the sine, this would be symmetrical about your y-axis. Okay, so that means this graph, it's going to look a little bit like a circle. Kind of a little pudgy here, but it's going to go down, have it here. This is going to go out. This is just a stinking wonderful ellipse here. And then there we go. That side's not too bad. Make the dot a little bigger. Looks a little bit like a circle, but it is really an ellipse. All right. So I hope that helped you see how to plot an ellipse and a hyperbola.